In today's video, we are going to understand the concept of Schmidt Orthogonalization procedure or GSO. So in GSO procedure, in digital communication, it creates an orthogonal basis set of functions for any given signal set, simplifying signal representation and detection by transforming complex waveform into vectors in lower dimensional signal space. So basically this GSO procedure is used for the signals which are complex. Suppose a transmitter transmits more than one signals and those are in the form of complex nature. So what GSO procedure does, this procedure simplifies those explanation by creating vector spaces which are orthogonal to each other. So to proceed with the formulation of the procedure, let us assume a set of m energy signals denoted by S1t, S2t, S3t till SMT. So let us see how mathematically we can create these sets. For that we assume m sets or m signals denoted by S1t, S2t, S3t and so on. Starting with S1t, first basis function is defined by phi1t is equal to S1t upon root E1, where E1 is what? E1 is the energy of this signal S1t, and this E1 can be calculated by E1 is equals to integration over 0 to t S1 square t dt. So from this formula you can calculate the energy of this signal, and the first basis function which is denoted by phi1t, it can be calculated by S1t upon root E1. So this way we can create basis function for all the signals starting from S1t till SMT. So one by one we will create the basis function S1t, S2t. So from this equation we can say that S1t is equal to what? Root E1 phi1t, and we will denote this by S11. So it will be S11 phi1t. So after this, now we will create the basis function phi2t. So after the basis function phi1t, now we will select the second signal S2t, and now for S2t we will take S21 which is equal to integration over the limit 0 to t S2t phi1t dt. This is how you can calculate the value of S21. Now after that, a new intermediate function is introduced for the further calculation, which is G2t. G2t is equal to S2t minus S21 phi1t, and the second basis function now can be defined by phi2t. In the first case S1t, we have defined the first basis function phi1t. Now we will define the second basis function phi2t. This phi2t is equal to G2t upon under root 0 to t G2t square dt. Again G2t can be written as S2t minus S21 phi1t. So continuing in this fashion, we can now define a general statement or a generalized statement which can create all the basis functions. So the generalized statement can be written as in this fashion: GIT is equals to SIT minus summation j is equals to 1 to I minus 1 Sij phi jt. This is the standard equation, you can say. With this standard equation you can calculate G1, G2, G3 and all the values, where Sij, this Sij can be calculated integration over the limit 0 to t Sit phi jt dt for j is equal to 1, 2, 3 till n. So that means for all the values of j you have to calculate from starting from j is equal to 1 to I minus 1. Suppose I is having value 3, so you have to take the value of j 1 as well as 2, because 3 minus 1 is 2, so it will move from 1 to 2. So that means for G3 you have to take two components, 1 and 2 both. This forms an orthogonal set. So suppose in the theory exams, question is asked, explain Schmidt orthogonalization procedure. So this much derivation is sufficient for the exam. There are two types of question which may be asked in the university exams. One is this, the theory question. Another, they can ask a numerical question on the basis of this. So after this we will solve a numerical. So the confusion regarding this I and J will be eliminated. So as I told you, that in the university examination there are two types of questions can be asked on GSO. One is the theory question, which we have already discussed. Another type of question which can be asked in the exam is a numerical based on this. So we will take a problem on the GSO method, and then you will be able to understand the concept very easily. So the problem is, using GSO procedure, find the set of orthogonal basis function to represent following signals. So there are three signals given, and you have to calculate the orthogonal basis function for all the three signals. So that means we have to calculate phi 1t, phi 2t and phi 3t, which are the basis function for S1t, S2t and S3t respectively. Okay, so the very first basis function phi 1t, which is corresponding to the signal S1. So as we have already discussed in the mathematical derivation part, phi 1t is equals to S1t upon under root of E1, where E1 is what? E1 is the energy of this signal S1t, and E1 can be calculated by the formula 0 to t S1 square t dt. Now this limit is moving from 0 to 2, so it can be written as 0 to 2 S1, value of S1 is 1 throughout, so it will be 1 square dt. So it can also be written as 0 to t dt, or t with the limits 0 to 2, or 2 minus 0 or 2. So E1 is 2 and phi 1t is S1t upon root 2. So this is how you can calculate the first basis function. Similarly, we will calculate the second basis function phi 2t as per the mathematical derivation discussed earlier. So now for the second basis function, we will first calculate the value of S21, which is 0 to t S2t phi 1t dt. Now this S2 signal varies from 1 to 2. That means we have to solve this question in two parts. One part from 0 to 1, another part from 1 to 2. In 0 to 1, the value of function is 1. So this is, and the phi 1t value is 1 by root 2. So this is 1 into 1 by root 2. And similarly, within the limit 1 to 2, the function is having the value minus 1. So it will be minus 1 by root 2. By solving this, you will get the value of S21 as 0. So now the intermediate function which we have introduced in the mathematical derivation G2t is S2t minus S21 phi 1t. Now phi 1t is 0, so this part will become 0. So that means G2t is nothing but S2t. So G2t is equals to S2t. Now we will finally define the second basis function phi 2t. Phi 2t is what? G2t upon under root 0 to t G2 square t dt. Now G2 is nothing but S2, so you can directly write S2t upon 0 to t S2 square t dt. Now S2t upon, when you solve this S square t dt within the limit 0 to 2, that means within the limit 0 to 1 and then 1 to 2, you will get the value as root 2. So the second basis function phi 2t is S2t upon root 2. Finally, after calculating the basis function of S1t and S2t, now we will calculate the basis function phi 3, which is representing the function S3t. After calculating the first basis function phi 1t and the second basis function phi 2t, now we will calculate the third basis function phi 3t. For that, we will have to take two coefficients S31 and S32. So S31 will be 0 to t S3t phi 1t dt, and S32 will be 0 to t S3t phi 2t. As far as S3t phi 1t is concerned, within 0 to 1, the value of S3t is minus 1. So it will, and phi 1t we know that it is 1 by root 2. So it will become minus 1 by root 2. And for 1 to 2, the function S3t is plus 1. So it will be 1 by root 2. So after calculating this, you will get the coefficient S31 as 0. Similarly, we will calculate the coefficient S32 within the limit 0 to t. So again, from 0 to 1, your function S3 is minus 1, so it will become minus 1 by root 2. And then from 1 to 2, your function S2 is minus 1. So because it is corresponding to phi to t, so that is why that is also minus 1 within the limit minus 1 to 2, so it will also minus 1 by root 2. So after calculating this, you will get the value of S32 as minus of root 2. So finally the intermediate function G3t will be S3t minus S31 phi 1t minus S32 phi 2t. But S31, as we have already calculated, as 0, so this part will become 0. So G3t will be S3t minus S32 phi 2t, where phi 2t is what? S2t upon root 2. So G3t will become S3t plus S2t, because S32 we have already calculated root 2 with a negative sign. So root 2 and root 2 will get cancelled, and minus will become plus. So G3 is nothing but summation of the function S3t and S2t. So by adding S3t and S2t, we will get the function G3t. So as G3t is summation of S2t and S3t, you can see S2t within the limit 0 to 1 is plus 1, and within the limit 0 to 1 S3t is minus 1. So it will get cancelled, and from 1 to 2 S2t is minus 1, and from 1 to 2 S3t is plus 1. So this will get also cancelled. So only remaining part is between 2 to 3. So the G3t will be between the limit 2 to 3, and it will be giving the value as 1. So now the third basis function phi 3t can be calculated by this formula, which is G3t upon root over 0 to t g square t dt. So it will be G3t, and the formula will become from 0 to 2, it will be becoming 2 to 3, because the limit existing only between 2 to 3. So between the limit 2 to 3, G3t is nothing but 1, so 1 square t dt. By solving, you will get the value as 1 only. So that is phi 3t is G3t. So this is the third basis function phi 3t, which is gt. So this way we have calculated all the basis function for the given problem. Phi 1t corresponding to S1t, phi 2t corresponding to function S2t, and phi 3t corresponding to S3t. This way we can solve the numericals also, if any numerical is asked in the exam.